I'm going to talk briefly about composite functions, and here we'll remind ourselves that the idea is that we have two different functions. Let's give these operations. So let's say that the first function is a 3x minus 1 machine, and we'll say that the next function is the square root of x machine. And the idea with composite functions is that when we put an input into the first one, let's say we have an input of 7, we get an output of 20. That new output becomes the input for the second function. And our final output after we go through two different functions, in this case is going to be 2 square root of 5. A couple of things to note about these two functions. So first of all, you'll note that x meant two different things in these two functions. Here x was equal to 7, but here x was equal to 20. So it's important to note with both of these, the notation uses the same variable, but in each case x equaled a different thing within the same problem. And the reason is you'll remember that x is just a variable that is standing in the place of the input of the function. And so they were different in each case because while we started with an input of 7, that input changed to 20 due to the first function and became a new input for the second function. We could give each of these functions names if we wanted to. We could call this one g of x. We could call this one f of x. We could pick any other name that we wanted. And a shorthand notation for this is f of g of x. And because of how order of operations work, we know that when solving this, we should always start with g of x first. So that one became first. And once we calculate the solution to g of x, we plug that solution into f of x. We'll remind ourselves that g of x is a shorthand notation for the output of g when x is the input. Okay. Now we could imagine with variables that any number could be plugged into our function. So let's imagine what would occur if we were to plug in a variable. Let's say the variable x. If we plug x into the first machine, the output is going to be 3x minus 1, which we could plug into the second machine, giving us the square root of 3x minus 1. And that gives us an equation form of our composite function. When we compose these two functions in this order, we get 3x minus 1. Now note that if we were to rearrange the order g of f of x, this would change the resulting function as well, because we would do f of x first. And in this case, f of x is the square root of x. So what we would be doing is we would be plugging the square root of x into the g function, giving us a result of 3 times the square root of x minus 1. So for composite functions, the ordering does in fact matter a great deal for what kind of equation you're going to wind up getting if you're working with equations, or what output you might get given different inputs into the particular function. So let's look at a couple of examples. We're given the function x squared plus 2x, and we want to simplify each of the following. Well, we're pretty comfortable with the fact that f of 3 means that we're going to plug 3 in for x. And so 3 squared plus 2 times 3, and simplifying that, 9 plus 6 is 15. And we could write the statement f of 3 is equal to 15, keeping in mind that 3 is our x value, or our input, while 15 is our y value, or our output. And we call them x's, y just as shortcuts for saying input and output. Next question says f of x plus 2 when x is equal to 3. So we'll go ahead and turn x into 3 plus 2. And from here we have a couple of options. One, we know what 3 plus 2 is, so we could turn it into f of 5. And we could plug that in. 5 squared plus 2 times 5. Notice that I'm putting the input in parentheses. It's a very good habit to get into, to put what you're plugging into a function in parentheses. It can help you with order of operations. I will point out, though, we did not have to simplify 3 plus 2 first. We could have chosen instead to input 3 plus 2 into our function before turning it into 5. And that would have just given us 3 plus 2 squared plus 2 times 3 plus 2. And you'll note that if you were to go ahead and add 3 and 2, these two statements are going to be identical to each other. So it's useful to recognize that you can plug what is inside the parentheses into the function before simplifying it, or you can simplify it first and then plug it in, and the result is going to be the same. Now, for this particular problem, I would imagine the vast majority of us would do it this way. That seems more intuitive, it seems simpler. But what if you were given, instead of f of 3 plus 2, f of x plus 2, and you are not told what x is? Since we're not told what x is, there is no option to simplify x plus 2. We cannot add x and 2. They are not like terms. We don't know what x is, so we can't turn this into something like f of 5. So we are forced to plug in x plus 2 into our function before the simplification process. But that's okay. X plus 2 is our input, and our function f of x tells us to square the input and then add 2 times the input. And we would want to go ahead and simplify from here, probably x squared plus 4x plus 4, remembering to FOIL x plus 2 times x plus 2, plus 2x plus 4, giving us a final function f of x plus 2 is equal to x squared plus 6x plus 8. Notice that the outcome here was a function, and that's because we plugged in something that had a variable in it. We did not just plug in a numerical value. Now, it is also possible to perform operations to a function. So here we have 2 times the function minus 5. And we'll keep in mind that this is, again, f of x, just a shorthand for either the output of the function or it's a shorthand for the function itself. This is the same thing as saying x squared plus 2x. It doesn't matter in the context of this problem which of those two symbols you write. They're identical to each other as stated at the beginning of the problem. So if I want to do 2 times this thing, 2 times my f of x function minus 5. And we would probably want to simplify this. 2x squared plus 4x minus 5. And that is what 2 times f of x minus 5 would be equal to. Few sample problems for you here. Got f of x, g of x, and h of x, and you're being asked to do a couple of different operations with them that will involve composite functions. So you can pause the video to see these 3 problems and work through them. In addition to that, once you've solved those 3, there are a couple of graphs here at the bottom. And the idea here is to try and make sure you understand input and output of function notation in order to read the graphs to provide a numerical answer for each of these 3 statements below the 2 graphs, and the 2 graphs are labeled for you there. And so you can pause the video either here or back at the first 3 problems. Once you are done working through these 6 problems, take a look at the answer key, which will be posted below, to make sure that you got the problems correct.